What's up, everybody? This is Matt Brown with another IoT hacking video. Today, we're going to take a look at a camera from Hikvision. That's right, Hikvision is the Chinese camera manufacturer that is most famous for being banned in the United States. So this has been ongoing for a while, but just recently here in the news, it's been upheld in a federal court that this ban, at least for now, is going to be in place, and these cameras cannot be sold in the United States. Now, there's obviously still a bunch of these cameras out there floating around, and so what we do on this channel is we take hardware like this apart and we analyze the security of the hardware itself. We're not going to get into geopolitics of whether or not these should be banned from certain markets. We're just going to tear it apart and see how it works and see if there's anything sketchy on this device. And so in this video, we're going to do a teardown, we're going to get UART, and we're going to get a limited root shell. And in later videos, we're going to try to break out of the jail that we are put into. So let's go over to the workbench and get started. So here we go. We got this camera. It's obviously one of these dome cameras that you mount up on a ceiling or an exterior roof or something like that. And so we are going to go ahead and take out. There's just 3 of these Torx screws here. 1, 2, 3, and for now we can zoom in a little bit. All right, so there's that, and oh gosh, this is always, they always like have these things to attach, so that way if you're like mounting this up on a roof, you can like have this like dangling down below, and you don't drop it onto somebody's head. That's what this is for. Pro tip, if you're ever installing a security camera. All right, let's just get that out of here because I don't want that. All right, so now we gotta go down one more layer here. A few more screws to actually get at the PCB underneath here. This camera is, you can power it with a standard power jack, but it also has power over Ethernet. So today, that's just going to be the simple way that we're going to power this device. I just have an Ethernet cord that I've got a PoE adapter on the other end. All right, so here we go. We are now inside of the PCB, and we are going to take a look at the other side, but first, let's just zoom in on this and just take a quick look at what we can see. So we see one piece of DRAM right here. We have got some, like your standard power components, your SD card slot, and then over here we have a very ominous unpopulated header with 1, 2, 3, 4 connectors. I think I'm zoomed in all the way I can go. Yeah, so that is obviously a candidate, a prime candidate for a UART connector, but we will probe that in a little bit. So now what I'm going to do is I am just going to, for the sake of doing a teardown on the hardware and kind of knowing what I'm getting into, I am going to, I got to get a smaller screwdriver here. And I'm gonna just take a look at the backside of this PCB. There we go. Got that screw. And then we'll go for this other one. Awesome. So now we're gonna go ahead and I think it's just those 2 screws. Awesome. So we're just going to take a little look at what we have on the other side here. Today we will be working mostly on the top side of that PCB, but potentially a future video we'll be doing some fun eMMC chip off and maybe some reballing. But here we have an eMMC flash chip, and then we've got a shield here, which, let me get a little bit of a smaller screwdriver to get some leverage here. So these are one of these shields that you can just pop off the cover, and we get a look at the two chips on top. So we have another piece of DRAM, so two DRAM chips total, and then we have our CPU. So that is not too interesting under there. Sometimes if it's a flash chip, I would leave it uncovered just to look at it further, but I'm actually going to put this back on because I'm not too concerned about that right now. All right, now we are going to flip this back over, and I'm gonna put these screws back on just because that will help keep the PCB from moving around on us. All right. Let's show what we're doing here. All right, because that way we have a solid base for connecting to our UART adapter, because we're not actually going to do any soldering today. We're going to use our PC Byte probes that I love to use so much. So there we go, and obviously I was hinting at it, but you know, the spoiler is that, yeah, we're probably going to find UART over here on this header. So we zoom in on that, and now I'm going to flip on my multimeter, and we're going to actually put that into continuity mode first. So we're going to take our probes, and we're going to simply find something that is ground on the board. So this shield right here and this SD card. We can confirm that those are in fact grounded. And so what I'm going to do now is if I'm looking for UART, I'm looking for, I need to connect to 3 pins on the UART interface. So one is ground, so that's kind of a given. You can get access to ground anywhere. But I want to figure out which one of these is ground, because then it's a process of elimination. I'm ruling out which pin I need to look for a digital signal on. So I'm going to go just across the top here. Nope, nope, nope. Okay, cool. So pin, leftmost pin is ground, and so that is good to know. And then we are going to now connect up. So again, this will be off screen, but we are going to be powering on the device. And with that on ground, oh, we need to switch into voltage mode there. Awesome. Yeah, we need to fix that overlay, don't we? All right, so now we're going to start probing on these other 3 pins. Okay, we have a solid 3.3 volts there. Second pin from the right, also solid if I if I stay on the pin. And then this other one, there we go. So you see that fluctuating voltage. That is a sign of our TX pin. So that pin is transmitting a digital signal. So we now know where ground is, leftmost pin, second leftmost pin is our transmit, and then we can make a pretty safe assumption that the next one over is going to be the receive pin, though we will have to test that. I have very rarely ever seen not seen you know, a TX and an RX next to each other. They're usually next to each other. So now what we're gonna do is we're gonna zoom out here, because now I get to use probably one of my favorite tools here in the lab, and that is these probes. So these are these PC byte probes. I've talked about them before, but it just allows me to connect to stuff and test things out without soldering. So they have, you know, these pogo pins on the end here. So we are going to do that, and I'm actually going to do this under the microscope because it is kind of annoying to do it otherwise. All right. So now it is a little harder to do it that way, but once we get it set up, it lets us know that we actually have a connection to our little connector here. So there we go. Make sure we're nice and in focus. Okay, so first of all, getting ground. I could connect to that leftmost pin here, right over here, this leftmost pin, but I don't need to, right? I can connect to here, this SD card reader, or what I'm gonna do is I'm gonna put a alligator clip on this shield right here, and that is going to get me my ground connection for my USB to UART adapter. So a little bit off microscope here. Just right there, I'm clipped on, we're good. So next, and we can get rid of this overlay, don't need that anymore. I'm going to connect up these probes to our 2 pins that we believe are UART. So first, I'm connecting, and it's not perfect here, so we're just gonna kind of have to rest at an angle there. All right, and then I'm gonna come in for that other pin from the other side. Oh, and that's exactly what we don't want to have happen. All right. There's one. And two. Okay. And my ground kind of disconnected, so we're gonna get that connected up again. Awesome. Now we're coming over to our screen here, and we have our command ready. So again, over there, what I have is 3 wires connected up, ground, TX, and RX, and that is interfacing with a UART to USB cable that we are going to interact with over this terminal emulator, which is PicoCom in my case. So we're going to do that. Oh, spoiler alert, the device is turned on. All right, so that means our connection works. Awesome. So let's reboot the device. So I'm going to very carefully take the the Ethernet cord out, because again, we're doing power over Ethernet. And so here we see the boot screen here, and we're going to make note of something. It's very important. Here you will see that it said hit Control U to stop auto boot. That's very important for later. So here we go. And then the other thing I'm going to start doing is just start hitting enter, and I can see that it's moving the terminal down, and that confirms that I have connected to the RX, right? And so when we connect our USB cable to the device, we are connecting the transmit pin of the USB, UART cable to the RX pin of the device, and vice versa. So we are connected up. Obviously, we're receiving data just fine because we can see it on the screen. And then transmit, we can test that by being able to hit enter. So that is awesome. And so what we're gonna do here is we are going to, you'll notice I hold down enter, and there's a bunch of junk here. But if I type help, let's scroll up, and you'll see that I actually have a shell here. So on this Hikvision device, just connecting up to UART, I get access to a shell, and it's even like you see it has the the hashtag symbol, right? Where'd it go? Okay, let's type that again. Help. There we go. Yeah, you'll see like I've got the hashtag symbol, so like I should be root, right? But obviously you know, okay, I'm going to type ls. Not supported. Try help. So on this Hikvision camera, the shell that they give you is this kind of restricted, locked down shell that only lets you run these certain set of commands that they want to allow you to have access to, right? And now they do give us some useful commands, right? And so one of those commands is PS, so we can actually view the processes that are on this system, and that is pretty helpful because then we can see what the name of the shell is that we are running. And you can see here that bin PSH is the name of that shell, which I believe that is some, intentionally locked down shell. I could be wrong. It could be a custom Hikvision thing, but they're clearly not giving you complete root access to your device. Now, these commands do execute as root. Now, there's some really interesting ones to actually prove my case. So if we look at one of these commands, okay, high dump, which is actually kind of an interesting command. So if I run that, it's gonna like ask me for the admin's password, but then like after it does that, it still runs this command anyway, which you will see it's running TCP dump. So TCP dump, right? So I can do high dump. Oh yeah, I can do like dash help. Oh, there we go. Okay, we were in the middle of TCP dump, right? Dash help. So we can see that high dump is just like some wrapper around TCP dump, which TCP dump, to be able to capture on interfaces, is usually going to require elevated privileges. And so, yeah, and obviously we can see that, everything is running as this admin user, which is effectively the root user. I'm pretty sure it's UID 0. And so we are root, but we're not, right? And so in the future video, what we're going to do is we're going to try to dump firmware on this device, and we're going to try to elevate this restricted shell and to escape from this jail we're in, right? Because we can see, another thing we can see here from PS is that the regular shell does exist. So we are running in this, PSH shell, but you'll notice that bin sh, just the standard shell, that also exists on this system, right? It's probably running BusyBox. It's an embedded device. And so bin sh is what you're going to have available. So if we were able to kind of escalate ourselves into that state, that would be cool. Now, I'm going to give you guys a hint of how I think I will be able to get myself into a position to get into the unrestricted shell. So I'm going to, you remember I said there was that thing in the initial boot up where it said you could pause the auto boot. So we're going to try to get into this device's bootloader now. So we're going to power cycle it. And I'm going to come over and pretty quickly hit Control U, and the boot process has stopped. And now we have this, this prompt says HKVS, so like, Hikvision something, right? But this is obviously U-boot, right? If you have ever interacted with the U-boot bootloader before, and you can clearly see they haven't like completely reskinned it. So this is some fork, some modified version of U-boot. And there's a bunch of interesting things that we can do in U-boot. And one of them is we can look at these environmental variables that are used to kind of set up the boot process. So we run print env. Here we can see that there's a bunch of environmental variables that set up various things so that the device can boot, right? That's what the bootloader's job is. And one of the variables we see here is called boot args. And then if you recognize any of this stuff here, you recognize that these are all Linux kernel command line arguments, right? These are command line, flags and stuff like that you can pass to the Linux kernel. And so what we can do is, if we want to, modify what program runs when you start up, we can sometimes get into a pretty limited, but full root shell if we change this init parameter to /binsh instead of linuxrc. So we will definitely go down that path in a future video, but I just wanted to show you where my mind goes when I have a device, I get UART, and I've got maybe have a little bit of a foothold on the device. I have some limited shell, but obviously, as a security researcher, I want to have a full unrestricted root shell, so that way I can start to use that for my dynamic analysis when I'm looking for security vulnerabilities in a device. So, and then, yeah, we have a bunch of other, interesting things here. Sometimes in U-boot you can actually dump flash, but I'm not seeing a whole bunch of those utilities here. But okay, so like load kernel to DRAM, that is one of the, okay, yes. And then the boot process, oftentimes you can see in these variables, these are like commands that get run. And so here you can see boot command is load K and then boot M. Well, those are both U-boot commands, right? So we have this load K, it's load the kernel to DRAM. So it loads the kernel and then boots the system, right? And then it runs this boot M thing here. So this is really interesting. So opt-T via Ethernet. So opt-T is, kind of like a security feature for some embedded devices. Okay, we have, some other stuff, but definitely don't see any like, eMMC dump tools for dumping flash here. They seem to be not compiled in to this version of U-boot. So that's too bad. We may have to resort to chip off, or if we can use this bootloader to manipulate ourselves into a root shell, then we can use that root shell to dump the firmware live from the device, and we don't have to go the chip off route. That is what I have for you today in this video. Thank you for watching. I hope you enjoyed this video. Please let me know what you think down in the comments, and let me know what you would like to do in the future. And if you have watched to this point and you're not a member of our Discord, definitely go and check out our Discord. That link will be in the description. Have a good day.